Before I begin today's video, I want to express my deepest condolences to the families and loved ones of those who lost their life in the tragic plane crash that occurred in Ahmedabad on 12th June 2025. May the souls of the departed rest in peace and may strength be granted to those enduring this unimaginable grief. Before we start the video, I would like to let you know that this video is not meant to censor ties or the incident or not to assign blame. Rather, as someone with a technical background, I felt the need to offer an informed perspective on what could technically lead to such a tragedy based on global aviation standards and official protocols. For example, just as we have ISO 27001 in IT or NIST Cybersecurity Framework to prevent failures or attacks in digital systems, aviation too is governed by extremely rigorous safety standards such as ICAO Annex 6, Annex 13, and India's Civil Aviation Requirements or CARs. These are not just guidelines, these are life-saving protocols developed through decades of experience and data. The investigation into this crash is being led by India's Aircraft Accident Investigation Bureau, along with experts from the UK's AAIB, the US NTSB, and the Directorate General of Civil Aviation. The flight data recorder has been recovered, and the cockpit voice recorder is being located, while no official cause has been released yet. Technical professionals can examine common failure points under similar conditions. In the upcoming part of this presentation, I will share 10 possible technical scenarios. So remember, no one knows what happened. So I'm going to share 10 possible that maybe out of those 10, there could be one issue which has led to this, ranging from landing gear issues, engine malfunction, hydraulic failure, all the way to avionics or human error that can lead to catastrophic failure during takeoff. These scenarios are not guesses, but well-documented risk points supported by aviation data, past cases, and safety audits. Each of them represents how complex systems require precise coordination and how even one misstep can cascade into disaster. My goal here is to educate, to raise awareness about the technical intricacies of aviation, and to help the general public understand that while flying remains incredibly safe, it is made safe through layers of engineering, human discipline, and constant improvement. Once the final report is released by the authorities, I will try to provide a follow-up breakdown with full technical details. Until then, let us all respect the process of the investigation and stand in solidarity with those affected. Thank you for listening. Let's continue to advocate for safety, transparency, and preparedness. And let's jump to the next slide. So, introduction, as we all know, this happened on 12th June 2025, which was yesterday. India faced a very devastating tragedy, and the aircraft was Boeing 787 Dreamliner, which crashed shortly after takeoff from Ahmedabad and claimed over 240 lives. Our analysis in this video, as I said before, is going to be the 10 possible technical reasons which may have led to this. So as per protocol, global agencies are now involved in decoding the aircraft final 30 seconds, because what has happened, the flight took off and it crashed in around 30 plus seconds. That's it. So the investigation team are led by India's AAIB, supported by UK AAIB, US NTSB, FAA, DGCA, aircraft and engine manufacturers. We are trying to recover the flight data recorder, which is recovered. However, the cockpit voice recorder is still being searched. Conditions are also being checked, like whether at takeoff, clear, normal. Now, as we discussed before, aviation relies on multi-layered protocol just like cybersecurity. each designed to catch a failure before it becomes fatal. Some global standards which every aviation follows is ICAO Annex 13 Accident Investigation, ICAO Annex 6 Operations of Aircraft. Some of the Indian regulations: DGCA CAR, India's Civil Aviation Requirement, Safety Management System, Proactive Risk Monitoring. These things happens. Like those who belongs to the IT part of the world can compare it to their ISO 27001, NIST CSF, etc. So let's look to the possibility one, the first reason, which could be a possible reason. Okay, landing gear not retracted. So unretracted landing gear increases drag dramatically, which can stall an aircraft during ascent. Some of the eyewitnesses says that gear stayed down throughout. And as we know, landing gear causes high aerodynamic drag. Without retraction, lift may not overcome weight. So this could be one possible reason. The next possibility, which everyone is indicating, is the engine failure or thrust imbalance, which may lead to power loss or loss in directional control. The investigation is focusing on FADEC logs and turbine wears logs. The third possibility could be of a hydraulic system failure, because if hydraulic fluid is low or lines are blocked, pilot may lose access to crucial flight surfaces within seconds. The fourth possibility could be of a FADEC or a engine electronic control fault. FADEC stands for Full Authority of Digital Engine Control. So a software level glitch in engine management can simulate a mechanical failure without visible damage. And the investigation evidence that we may need to check is the data which is logged in the FDR for post-crash analysis. The fifth possibility could be of a fuel system irregularity, because jet engine requires precise fuel flow. Any disturbance during climb out can be catastrophic, and the potential issues could involve incorrect fuel pressure, valve or pump failure, fuel contamination. It could be anything. And this is one of the regulatory focus parameter under DGCA as well. The sixth possibility could be of a improper flap configuration, because improper flap deployment has caused multiple past accidents, especially during manual override or checklist rush. And the risk factor is like too little stall or too much drag, which can lead to flap failure or checklist, or maybe both, right? Seventh possibility, everyone is indicating that there could be a possible bird strike, which we also call FOD, foreign object damage. And birds or debris can severely actually damage the turbine blades or flight sensors during takeoff roll. The eighth possibility could be avionics or sensor malfunction, because misleading instrument readings can lead pilot to overcorrect or underreact during high speed climb. The ninth possibility could be a human error, like a pilot error or a skipping of a checklist, right? That even well-trained crews can miss small but fatal items when under stress or time pressure. 10th possibility could be a maintenance oversight or unresolved snags, because even a single overlooked defect can cascade into multiple failures if not diagnosed on time. So DGCA has flagged need for a 15-day snag reviews. They are like also compounding risk that the known minor fault which could be left unresolved may have led to this, and maintenance records are also under scrutiny. Now let's understand what safety mechanisms are in place and what might have failed. So modern planes are built with backups, but a failure of two interlinked systems at once leaves no room to recover. So this could be one reason. Let's see in the investigation what everyone finds out. So what's next going to happen in investigation? So our data analysis is already in place, where a full FDR analysis is happening. for engine pressure, gear position, and thrust level. People are also trying to retract voice recording that what the pilot said in the last 30 seconds. So CVR is still awaited for pilot conversation and warning alarms. Also, fleet review is happening, like all Boeing 787 are under review by DGCA. Then regulatory actions are also being taken place, like further alerts or airworthiness directives may follow. The final report, whenever it will be released, will detail the full chain of events and issue preventive mandates. Some final thoughts and broader reflections. So, small problems that align without backup may lead to 3-4 critical failures. There are already 100 plus safety systems in place. When a flight takes off, it goes through those checks. Even a single causes, which is like very rare, one in a million chances, may lead to this failure. So, just comparing it from cybersecurity, aviation basically runs on system layers and real time data. And like in any critical system, small failures may stack fast. No plane crashes for one person, it crashes when 3-4 small problems align without a backup. So, this is one in a million scenario. Hope this remains the last. That will be the last wish for everyone. Let's see how uh, it comes up as an event or as a learning for the future aviation industry. Some call to action. If you have watched this video till end, I would like to understand from your perspective what possibility you most likely to see. Comment below with your thoughts. Subscribe for more technical background breakdowns when the final AAIB report is released. And I will say one thing, that let's understand, flight still is the safest mode of travel. The number of accidents which has happened till date since the history of aviation is really less compared to any train or any road trip when you travel on a bike or on your car. The chances are really the least compared to any other mode of transport. This is surely a biggest failure and a very big loss to everyone who was there in the flight, and even to the countries and industries which are involved in that. But we have to learn and go from here. That's how the industry or the humanity works. Thank you so much for watching this video. I would like to know your comments. And again, sorry if the video was long. This was not to sensitize, but to educate everyone. Thank you so much for watching this video.